What is up everyone, welcome back to a brand new video. In today's video we have something super exciting because today we are going to be building the Demon 2.0 electric skateboard. This insanely powerful electric skateboard has a top speed of 38 miles an hour, a range of up to 30 miles, and a hill grade climbing of over 30%, putting it in a league of its own. And the best part about it is that using all of the parts from our online store Propulsion Boards, which is in the link below, you can build this board. It's pretty much all plug and play. No soldering required. We've made the build process even easier this time by making a product that's a kit with all of the necessary components. And if you guys don't want to build it, we're also selling this board as a pre-build right now for $1999.99. So make sure to go check that down in the description below. But without further ado, we're going to get into how to build this absolute monster of an electric skateboard. When starting off, the first part they're going to need are these motor mounts, which are made from 6061 aircraft grade aluminum, so they're super durable. They're made to fit our own board / Evolve clone double kingpin trucks, and they're super high quality. The black finish on them looks incredible. Next we have our motors, which are a custom 6374 190 kV motors from Flipsky. They're battle hardened and they have a custom shortened 10mm D-shaped shaft for added performance. You guys should go check out the video review that we made on these motors. They're absolutely incredible. They're going to make the build process from the 1.0 so much easier, and they're also just cleaner overall. In terms of the connectors, we've got a custom 6-pin that already fits the VESC for the sensor wires and 4mm bullet connect. Simply just screw the 4mm cap head screws in through the motor mount, and once you've got them in a little bit, you can use an Allen key to secure them all the way down. Once you've finished doing this for the first motor and motor mount, you'll want to do this for the second motor and motor mount, doing the exact same process. At this point, you've got both motors secured to their respective motor mounts, and you'll just want to make sure that the wires coming out of the motors are orientated at the proper angle to face the enclosure. The next part that you guys are going to need are these double kingpin trucks, which are our Propulsion Boards double kingpin trucks. These trucks are identical in dimensions to both the Evolve and the Onboard double kingpin trucks that are common in those pre-built boards. We just have our own custom version used perfectly for the Demon 2.0. The first thing that you're going to want to do is to slide the motor mount over one of the axles and then slide the other mount over the other axle. At this point, you'll need these 6 cap head M5 screws to bolt the motor mounts into the truck. You'll also need the nuts that fit those. Simply align the 3 holes in the motor mount with the 3 holes on the mount built into the hanger, and then put the 3 cap head screws through both of them. Once this is done, you'll be able to flip the truck around and then put the bolts on the other side to secure the mounts onto the hanger of the truck. The easiest way to do this is to first thread the nuts on simply using your fingers, and once you've got a good grasp on them, you can use an Allen key and a wrench. This process is quite tedious using just an Allen key and a wrench, so if you guys have a driver and the proper hex bits, we would highly recommend using a driver, the proper hex bits, and a wrench to secure your motor mounts to your truck. However, all that's technically needed is a set of Allen keys and a wrench. Once you've finished doing this process for one side, you'll want to do this for the other side for the other mount, repeating the exact same steps as just shown before. At this point, the drivetrain is really starting to take place, and you can start to see how this Demon is going to form. Those 6374 motors on the back look absolutely massive already, which brings us to our next part, which is going to be our motor pulley. This is a steel motor pulley, which is upgraded from our last one, which was aluminum, and it has a D-shaped shaft to fit our D-shaped motor. Not only does this make it easier to grip to the shaft of the motor without a set screw or a keyway, it's also just a lot easier to assemble. So the first thing you're going to want to do is to just slide it onto the shaft, and boom, you're done just like that. It's mounted to the shaft, and when you rotate it, the shaft will rotate with it. All that you have to do to secure it to the shaft for good is to install the set screw and screw it all the way down. It's crucial that you apply Loctite in this step. We didn't show it at this point, but applying Loctite is very important to keep the set screw still. The next part you'll need are our belts, which are 290mm long, 15mm wide HTD5 belts. These work great for the project, and they're super durable. Next, we have the wheel pulleys, which are these 38-tooth Kegel wheel pulleys that are 15mm wide. These will align perfectly with our 15mm wide 5M pitch motor pulley and belt. What's particularly nice about these wheels pulleys is that they are bearinged wheel pulleys, which means they snap right into the desired wheel, and then they sit right on the axle. There's no need to bolt anything, they just pop right in. These pulleys work perfectly with the wheels that we're using, which are these 110mm really big wheels and the 72A Arctic Blue durometer from Torqueboards. Simply put, these electric skateboard wheels are massive, and you can't build a high quality DIY electric skateboard without the best wheels to improve the ride. Not only are these super big, but their soft durometer makes them super grippy to the road, and that wide contact patch makes all the difference for making your ride that much better. For the bearings, we're going to be using some Red's Bones high precision skate bearings, which we found to be excellent bearings for building DIY electric skateboards. To install the bearings, first slide one over your axle and then press it firmly into the wheel using all of your force. It should make a popping sound right when it pops into place. Next, you'll want to get the second bearing in, but first place it onto the axle and then put the spacer in between, and then repeat the same process of pressing it firmly into your wheel, and then do this for all 4 wheels. At this point, you can install your wheel pulley, which is simply done by pressing the wheel pulley into the inside of your wheel, and the kegel core should just match right up and pop straight into place. This is that really nice feature that I was talking about with these bearing pulleys. They just snap in so easily. They're super easy to take out and put in any single time that you want to swap your wheels. Keep in mind, if you're swapping your wheels, you'll need to swap your wheel pulley for the corresponding core. Next, we begin the assembly by placing the belt over the hanger and the wheel pulley so that it sits loosely, and then you can put the wheel onto the axle and then slowly rotate it, moving the belt over the pulley and slowly turning it until the belt and pulleys naturally align. It's important that your motor is set to a loose position, that way the belt is nice and loose when you're pulling it on, and then once the wheel pulley's on, you can pull the motor back until your desired tension is there and secure all of the screws that attach the motor to the mount. At this point, it's also crucial to apply thread locker or Loctite. This way, your screws won't come loose while riding. We ensure that we use Loctite on all Demon 2.0s. You'll also want to make sure that you repeat this process for your other wheels so that you have both wheel pulley drivetrains set. Next, we have our belt covers, which unlike the 1.0 actually fit perfectly on due to the fact that we have a new custom motor shaft. They're super easy to install, and all you have to do is to line up your belt cover with the edge of the motor mount, and the holes between the two should automatically line up. Use the 2 M4 bolts provided, then place them inside the holes on the belt covers, and then use an Allen key to screw these into the threads already in your motor mount. You'll want to make sure you repeat this process for both sides so that both sides of your drivetrain have belt covers on them. I think that this is one of the nicest features of the new Demon 2.0, because the last 1.0 really didn't have a clean looking drivetrain because the belt covers couldn't fit on that easily without shaving down the motor shaft, and now this drivetrain assembles super easily and is very modular. So once you've finished this, you'll just want to screw the axle nuts over your wheels, secure them using a T-tool until they're to the contact, such that the wheel doesn't rattle anymore, but so that you're not so hard that the wheel doesn't rotate, and then you'll do this for the other wheel too. At this point, you've finished the drivetrain, and I think that this drivetrain looks absolutely incredible. It's super easy to build, it takes less than an hour to complete, and we actually sell this as a product on our online store, Propulsion Boards. It's called the Complete Mechanical Kit, and you can buy it with ABEC wheel pulleys if you're using ABEC wheels, or Kegel pulleys if you're using Kegel wheels. The wheels are not included, but if you're interested in just building this drivetrain, this is a great option for you. The link will be in the description below. It's so nice because the cables come out all nice and clean with these braided cable sleevings, and we also offer an all-terrain version using our 7-inch all-terrain conversion kit, so you can just simply pop these all-terrain tires on. There's no issues with the motor pulley hitting the wheels because it's been designed so that they'll fit. Moving on to the deck that we are using is a drop-through downhill deck. It's 37.5 inches long, and all of the holes are pre-drilled into the top of the deck to fit the enclosure perfectly. We found that has a nice amount of concave to work for builds perfectly, and the drop-through is also super nice on those double kingpin trucks. We've also had an enclosure custom made by the legendary West Coast Standard in Psychotiller that matches up perfectly with the deck, so it molds perfectly to the underside, and all of those holes that you see on the enclosure will match perfectly with all of those holes on the deck. I cannot say how amazing of an enclosure solution for DIY builds this is, but it's also going to look sick on the Demon 2.0. Everything matches perfectly and has been made to work together. We are using 16 of these threaded nut inserts that are the M4 size to secure the enclosure to the deck, and they're going to be paired with some 18 to 20mm M4 cap head screws. The threaded nut will go on the top of the deck, and then the screw will go through to the bottom of the deck and screw into it, holding the enclosure in place, and we'll also have some washers to spread that pressure from the screw, and you can see all of the fasteners right here. As we said before, all of the holes on the deck match perfectly with the enclosure, which is super nice because you don't have to do any drilling yourself. and it makes any DIY build solution for an enclosure super duper easy, and it just looks incredible. So the first thing that you're going to want to do is to screw all of those threaded nut inserts into the top of your deck, preferably using a drill or a driver with the proper hex bit, and you just screw them down till they go all the way in, and you'll do this 16 times for all 16 of those. Screw all of the threaded nut inserts so that they're flush with the top of the deck, so that when we put the grip tape over, it'll be all nice and flat. This can be tricky since oftentimes you'll put them too far or not far enough, so you want them to all be the right size. Next, we've got our grip tape, which is our new custom propulsion boards grip tape, which is specifically made for the Demon. This is a limited edition grip tape. We've actually only made around 10 of these, so the first 10 Demon 2.0s will get this special limited edition propulsion boards grip tape on them. All future Demon 2.0s will have a similar grip tape, but it won't be exactly identical to this first 10 batch, so make sure you pre-order now to get this limited edition grip tape on your Demon 2.0 and be one of the first 10 people to get a kit or order one of these. So you're just basically going to want to put this grip tape on top of the deck that we've just put all those threaded nut inserts onto, and it's a pretty simple process. There's lots of videos teaching you guys how to do grip tape, so just do that and it should end up looking like this. The nice thing about the threaded nut insert design is that there's no visible markings on the deck that show how the enclosure is held into place. All you can see is this nice flush grip tape on top, and I think that it looks incredible. The next step that we can move on to is mounting the trucks to the deck now that we have the grip tape on. Basically slide the trucks through the back end of the deck and then use the skateboard hardware included with the kit. We have some 1032 nuts and screws. They're super easy to use, nice hardware that's nice and long to allow you to use shred lights or any other accessories. Just screw them through the top of the deck, pierce them all the way through the grip tape, and then add a washer with a nut on the bottom. You'll also want to make sure that you do this for the front truck. Pretty standard process, and it's nice that we have this nice cutout in the front of our deck, which means that for a drop through style we won't have to remove the truck and take it apart. To tighten the skateboard hardware, you can just use a driver or a screwdriver and your T-tool. Next, we're going to mount the wheels, which is simply done by putting a speed ring on, then your wheel, then another speed ring, and then the nut on the top. You can then repeat this exact same process for the other wheel and then tighten the axle nuts using a T-tool. That way the wheels are securely secured to the truck. With the trucks mounted to the deck, the Demon 2.0 is really starting to take shape, and it looks super sick already. With the mechanical system done, we're now going to move on to the electronics. The ESC that we're using for this build is the Fockbox Unity Plus, which is the most tested and reliable VESC on the market. Not only is this ESC super powerful, but it's super user-friendly and has a Bluetooth module integrated. We've got a female XT90 for the battery and 4mm bullet connectors for your motors. We found this thing to be super easy to program, super user-friendly, super powerful, and overall it's our favorite ESC to use right now on the market. It's overall just an incredible VESC, and we're going to be pairing it with the FlipSky VX2 remote, which is our favorite remote to use for our DIY electric skateboard builds. Not many DIY electric skateboard remotes have all of the features that the VX2 includes, which include a reverse mode, 3 different speed modes, telemetry display, and many other features that most remotes don't include. It also sits really nicely in the hand and has great battery life. To connect the receiver, simply plug the 4-pin connector into the 4-pin on the VESC, and then you'll have the VESC 4 cable, which will go into our Unity because it has a VESC 4 version UART port on it. For the battery, we're using our new custom 12S 3P Samsung 40T battery pack. This pack is an absolute beast. It uses only 36 cells, but it still has the exact same power output and capacity as our old 12S 4P battery, meaning that the Demon 2.0 has a slimmer profile but still packs the same punch in the exact same range. Overall, it's just a complete upgrade from our old 12S 4P, and these new 40T cells have very little sag. The next thing that we really like to do is kind of a dry fit / loose fit of all of the components inside of the enclosure so we can get an idea of how everything's going to sit once it's inside. So we just take the battery and take the ESC and kind of shuffle them around until we get our desired orientation. We found that having the battery on one end and the ESC all the way at the other is the best way to go. The ESC will go on the end with the farthest space holes on the enclosure. There's some different spacing between the holes. It's not completely symmetrical, so keep that in mind. Everything fits in there nicely and will leave enough space when it gets hot. So the next thing that we're going to want to do is to make the holes in the enclosure for the charge port and also the power switch. Find a place on the side of the enclosure where you're not going to hit any of the other internal components, and then just mark it and drill a hole in the side of the enclosure that's the same diameter as the component. So the charge port should be a little bit smaller than the power switch since the power switch has a larger diameter. It's really important that these holes are nice and snug on the components and not too big. The next 2 holes that we're making are the holes for the phase wires to come out of the enclosures to the motors. So what we do is we drill a hole in the back of the enclosure 20 millimeters from the center on each side, and this kind of leaves two little holes for those phase wires to pass through. We then take a Dremel, cut those sides off so we kind of have this nice little semicircle rectangular channel that the wires will be pressed against the deck with. We found this to be the most clean and efficient way to get our wires from inside the enclosure to the outside. It's not waterproof by any means, but it makes the build look nicer. In the end, it should look a little something like this, which is pretty clean, and once those phase wires get in there, it'll look like there's no holes at all in your enclosure, and overall super good. So next you'll want to start threading all of those components through your enclosure. Just place them through that hole and then use the locking nuts to secure them on the inside of the enclosure. You'll want to do the exact same thing for your power switch. Once again, take the threaded nut, tighten it to the edge of the enclosure, and they should sit nice and flushly with the edge. We can now place the battery inside and see that it fits perfectly, and then the unity inside. At this point we can get serious with rearranging the wires and connecting everything. We connect the XT30 on the battery to the XT30 on the charge port so that we have the charge port wired in. We then plug in the power switch to the unity by plugging it into the 5-pin on the unity port, and then we plug in the battery to the ESC using the XT90 connectors. Lastly, connect the phase wires of the motor to the phase wires of the ESC. Take 3 phase wires from one side of the unity into one of the motors, and then take 3 of the other phase wires on the other side of the unity to the other side, and then plug in the sensor wires to the sensor port on the respective sides to the corresponding motor. What's really nice here is that our motors already have the 6-pin sensor wire and you won't need an adapter. They've just plugged right into the VESC. To attach the battery to the enclosure, we use this super sticky adhesive double-sided tape. It's more of a super double-sided tape because once you put this thing on, it does not come off. We then insert the battery into the enclosure and it's pretty much locked in there for good. Just apply some pressure evenly and make sure that it's stuck on nicely. We also like to add some nice silicone sealant just around all of the joints so that they'll stay put. We do this around the power switch, that way no water can get in there, and also that the ring won't come loose and the power switch will stay in place. We do the exact same thing for the charge port, that way it won't move even if it becomes loose, and also just to provide a little bit of protection against dust and water. Hot glue also works really well. We then attach the unity inside of the enclosure using that same double-sided adhesive, just applying 2 strips on the unity so that it can't rotate and it'll stay put inside of that enclosure. Another solution that works really well, and if you want to keep tinkering with your board and messing around with things, is to use some Velcro. Just put one side on your enclosure and the other side on your ESC. This way you'll be able to remove it. With all of the electronics hooked up, it's now time to program the unity using VESC Tool 2.05. Turn on the unity, then plug in the USB-C to your computer, and then open up the VESC tool. Alright, so here we are in VESC Tool 2.05, and now I know this isn't the newest VESC version, but we are using it instead because I'm on a Mac, and that's the newest VESC tool release I could find, so we're just going to click Auto Connect. It should auto connect, and we're going to go to Set Up Motors FOC, Medium Outrunner, Next. We're going to click Yes. Battery cell series, we're going to click 12. Battery capacity, we're also going to click 12. Next. Motor pulley is going to be 15. Wheel pulley is going to be 38. And then our wheel diameter, 110 millimeters. And then we're going to click Run Detection. OK. And that's going to spin our motors and get the detection results that we need. Make sure that your motors aren't touching anything or that they could hit anything, because this is going to spin them just like that warning says. Okay, so now we have the detection results and all of these look good. It's important that you have Hall sensors here, and that this motor current is around 75 to 80 for both. We're going to click OK, and then we're going to set the direction we want each motor spinning so that it goes forward when we click go on the throttle. So we click this one, which is spinning the wrong direction. We'll click inverted, and now that's forward. And this one is already the right direction, so we'll click finish. For the input, we'll go to Setup Input, Next, and then we'll click this VESC right here. Next, click PPM. We can ignore everything here. Scroll down, we can write in traction control if we want, not necessary. Write that configuration to VESC, Next, and Finish. And now we can go into our General tab here. To get the most out of our motors, we can set the motor max current to 80 is what I like to set it to. And then braking, I like to set it to around -70. That's pretty strong braking already. And then we'll go over here and we will click Write Motor Configuration. We also want to go into General and make sure that we have PPM and UART selected because we're using a VX2 which is going to use UART, so it's important that that is checked. And just like that, you should be good to go. Lastly, we can plug the receiver into the VESC by using the 6-pin UART port. Simply just take the 6-pin JST from your receiver, plug it into the 6-pin on the flock box, and then mount your receiver on the side wall of the enclosure, and it should be good to go. As a final step before sealing up the enclosure, we're going to add this window sealant gasket around the edge of the enclosure. It has an adhesive side, so all you have to do is remove that sticky tape and then stick it to the edge of your enclosure. Just put it nice all the way around the rim, and it'll keep some of that moisture and dust out and provide a seal with your deck. At this point, all that's left is mounting your enclosure to the deck, which we do with 16 of those 18mm long M4 cap head screws. We use a washer underneath the head of the screw, that way it spreads out the pressure and won't crack your enclosure. You're just going to want to drop these in and slowly screw them into all of those 16 holes, loosely placing them all in a line first, and then once you've got all of your screws laid in, you can use a driver or an Allen key to screw them all the way into your deck and hold that enclosure in place. It's important that these are screwed down tightly, but not too tightly, otherwise it could crack your deck, but you also want to make sure that there's a nice seal between your deck and your enclosure so nothing can get in. And just like that, now that you've mounted the enclosure to the deck, the build is done. This is what the finished project looked like, and this board is absolutely insane. Alright, so there you guys have it. That is how you build the Demon 2.0 DIY electric skateboard. If you guys want your very own Demon, go make sure to check the description below. We'll have a link to the kit which will include all of the parts that you need to assemble your very own Demon 2.0. Also, if you guys are instead interested in purchasing a Demon 2.0 already pre-built, we'll have a link down in the description. The Demon 2.0 is so much fun to ride. It's super quick right off the line. It just accelerates like no other DIY board or pre-built board out there. The range is also incredible, and the top speed that this thing can hit is insane. We can't even take it up there on a regular basis because it's just so scary. So if you guys are looking for a speed demon, this is going to be a perfect buy for you guys. Also, it has a good amount of range like we said before, and the hill climbing is going to be extraordinary. We've tested it on this hill, which is around 30%, and believe me, it just cruised up this hill. We didn't even hit all the way on the throttle, so it can climb plenty steeper than this one. Anyways, thank you guys so much for watching. If you have any questions about the Demon 2.0, drop them down in the comment section below. Also, if you enjoyed the video and you've made it this far, please consider liking and subscribing to our YouTube channel for more awesome DIY electric skateboard contents. Last but not least, make sure to go check out our online store, Propulsion Boards, for all of your DIY electric skateboard products and needs. Thank you guys so much for watching, and we'll see you guys in the next video.